Today we are going to be looking at section 2 of chapter 4, which looks at some different ways to be able to prove triangles are congruent. So I refer to these as shortcuts. What we learned in section 1 that we just went over homework with is if we wanted to say that those two triangles were congruent, we again would have to show all three pairs of sides, all three pairs of angles. As we progress through these next few sections, we're going to learn some different shortcuts. Today we're going to talk about two of them. Okay? SSS stands for side, side, side. And then SAS stands for side, angle, side. So instead of having to show all 6 things, 3 sides and 3 angles, if we have these 3, that's enough to be able to say that they are congruent. So if you look at the side, side, side piece in your interactive notebook, okay, our side, 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 or SSS postulate says, if the 3 sides of one triangle are congruent to the 3 sides of another triangle, then the 2 triangles are congruent. So what I want you to do on the picture of those 2 triangles that are in your notebook is to put in those corresponding tick marks. So again, if we know all 3 pairs of sides are congruent, whether they tell us that or we know it somehow, we don't have to worry about the angles. If we have all 3 pairs of sides congruent, that is enough to say that those triangles are congruent. So that's side, side, side postulate. The other one that we're going to work with today is the side, angle, side postulate. This postulate says if 2 sides and the included angle of one triangle are congruent to 2 sides and the included angle of another triangle, then the 2 triangles are congruent. So with side, angle, side, order is important. We saw those words included, angle being used. Okay? Based on the 2 sides that are known to be congruent, it has to be the angle that is between those 2 sides or formed by those 2 sides. Okay? The 2 sides form angle A. The 2 sides form angle D. So it has to be that included angle between the 2 sides. So that's our side, angle, side postulate. So there are some other shortcuts that we will be using and learning about throughout this unit. Today we're just working with these 2, side, 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 and side, angle, side. So if you look at the next page in your interactive notebook, we have some triangle hints that we want to talk about. Last week when we looked at section 1, one of the things that we talked about was the importance of marking information in your picture so that you can see it. You need to mark things that you know to be true. Sometimes students look at a picture and say, well, I think these are the same, so I'm going to mark it that way. We only mark what we know to be true. So one of the things that we're going to see, which we saw today when I talked about this problem number 8, was that reflexive side. When a side is shared, we use that reflexive piece. So in this diagram, I have that side PR, which is in both triangles. So that is reflexive. It is congruent to itself. So I'm going to put a tick mark on that line. because I then know that PR is congruent to PR. So that gives me a piece of information that is needed to be able to say the triangles are congruent. In this next one, we have a quadrilateral, which that reflexive side then cuts into two triangles. So again, I'm going to know that that side, I'm going to use 3 tick marks. I can't use 1 or 2 because 1 and 2 have already been used. So I put 3 tick marks on there because I now know that side HF is congruent to itself. And the reason would be that reflexive property. So that's one thing we always want to look at in our pictures, or do we have a shared side that we can mark? Another thing that we're going to take a look at that we've been working with for several different units now is that idea of vertical angles. Anytime 2 lines intersect, we have those vertical angles formed. One arc has already been used, so I'm using 2 arcs because I now know that angle WXV is congruent to angle YXZ. Remember, with those vertical angles, we have to use 3 letters to name them. We can't just use a vertex because the vertex is shared. Similar thing in the next diagram. I've got those vertical angles. So I know that angle DEB is congruent to angle AEC. So that's another thing that I'm always going to look for. Do I have vertical angles that I know to be congruent? Third thing that I'm going to look for is that idea of a midpoint. That was something that we learned back in our first unit. We have a statement that tells us E is the midpoint of segment KW. If E is the midpoint, we know the midpoint cuts the segment into 2 congruent parts. So I know that segment KE is congruent to segment WE. In that next example, D is the midpoint of segment MT. So again, I know that's been cut into 2 congruent parts. So I know MD is congruent to segment TD. So that gives me a pair of sides that I know to be congruent. And then angle bisector, which again is something that we learned in our first unit. Angle bisector, we need to look at carefully of what is being bisected. So it tells us that AD is the angle bisector of angle BAC. So angle BAC is up here at the top, which means that angle has been cut into 2 congruent parts. Okay. You can put just the arcs on it. You'll notice sometimes in the book you see that they'll do an arc and a tick mark. Okay. It's just another way to show it, okay. But just the arc is fine. So I know that angle BAD is congruent to angle CAD. But important to read, we're being told that it's bisecting angle A up above. Okay? Sometimes people want to say it bisected angle D. That's not what we're being told, so we cannot make that assumption. And this next one says that DC bisects angle ACB. So again, that top angle is being bisected. Here, because they have the angles numbered, when I write my congruency statement, I can use those numbers and say that angle 1 is congruent to angle 2, rather than using 3 letters to name the angle. So because our focus now, again, is on triangles, we want to think about these things because that's where we can get information.
So when we get it wrong, we still use the letters? Or no?
No, you can use the letters, okay? For this one, Ian's asking if it would be wrong if you use the letters. No, you could name the angle ACD and BCD. Okay, that's okay, but you can also use the numbers since they were numbered. So, next thing we're going to look at is some of the proofs in our proof booklet. So, these proofs are numbered, and they're also titled, which kind of gives you a focus. Okay? We know in this first proof that we're going to be using side, side, side. So again, that kind of gives us an idea of where we're headed. Okay? At the end, we need to be able to say our triangles are congruent using side, 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 which means we have to use or mark in our picture all 3 pairs of sides. For these proofs, in your book, you'll notice all of these little rectangles down at the bottom. Okay? That is the information that we're going to be using, so it's kind of a matching activity, okay? Because they've given us that information down below. We need to get it filled in. So what do we typically start our proofs with?
Given.
The given information. So when I look up above, I know that I can do that. Okay? So I know that PQ is congruent to ST. And let's see, in your book, do they list those all separately? Yes. Okay. So I wrote that down wrong. PQ is congruent to ST. That is given. We have QR congruent to TR, which was given. Okay. So I'm going to go ahead and mark those in my picture. So PQ and ST, I use 1 tick mark. TR and QR, I'm using 2 tick marks. Now those are things that I can mark in my picture. And then my third given is that R is the midpoint of PS. That is given. That's not a congruency statement, so I can't mark anything in my picture yet. But they gave me that statement for a reason. I can't mark anything, but it needs to then lead me to something that I can mark. So if R is the midpoint of segment PS, what would my next statement be? When I look, if R is the midpoint, what does that tell us?
PR is congruent to SR.
Okay, so PR is congruent to SR. And what is the reason? Definition of midpoint. So now that I have that congruency statement, I'm going to mark it in my picture. So I have all three pairs of sides marked congruent. So my last statement is going to be what I want to prove. Triangle PQR is congruent to triangle STR, and the reason is side, side, side. So, not too bad, right? So again, we have to show those three pieces of information to be able to say the triangles are congruent. Second one we're going to look at, again, we know we're headed to side, side, side. We'll just start with our given. L is the midpoint of segment JN, and that is given. Okay. Sometimes in a proof, there is more than one way that you can order things. Some people like to start and just put all of the given down first. Other people may want to, because we have this statement that we can't mark anything, they might want to go ahead and extend this one first. Okay, so that next part follows, which is what I'm going to do here. So if L is the midpoint of JN, what does that tell us that we can mark in our picture? Okay, so I know JL is congruent to NL, or it might be different in your book. So now I can mark it. And what's the reason for that? Okay, we saw that word midpoint, so we're using the definition of midpoint. Okay. Now I'm going to go ahead and finish with my other given and do segment JM is congruent to segment NM. And I'll mark that JM and NM. Okay. So again, if you were doing this proof by yourself, this second and third statement, those could have been switched around. Okay. Because again, they're things that you know without using anything else. Okay. So I've got two pairs of sides. I've used all my given information. What else do I know when I look at my picture?
Ln because of the reflection property.
I've got that shared side. Okay, so I have that reflexive property. Okay, so I'm going to say LM is congruent to LM, and that is reflexive. And now I have all three pairs of sides marked. So I know that JLM is congruent to triangle NLM using side, side, side. So in addition to that given information, we also want to think about those triangle hints that we were looking at. Next one, looking at the heading, this gives us side angle side. So again, kind of guides us to what we want to use. Again, we'll start out with the given. So I know X is the midpoint of VZ. That's given. So again, we could go ahead and write the other given. I like to just go ahead and continue with this piece. Otherwise, we tend to forget about it. Okay? But it was given to us for a reason. So how does that given statement help us in our idea of proof? If X is the midpoint of segment VZ, what do we know to be true? Okay. VX is congruent to ZX. And that is definition of midpoint. Okay. It's cutting the segment into two equal parts. Then we have our other given. X is the midpoint of WY, which is given. So similar to the previous, now we have this other segment, which is being cut into two congruent parts. So WX is congruent to YX, and that again is definition of midpoint. So I used my given and what that given led me to. What else do I know to be true when I look at my picture? Okay. I have those vertical angles that are congruent. So angle WXV is congruent to angle YXZ, and that is vertical angles are congruent. So now when I look at that, I have two pairs of sides. The angles are included. They're formed by the two sides. So then I know what I'm trying to prove. Triangle VWX is congruent to triangle ZYX. And that is side, angle side. One more side angle side proof. So again, my first given statement, XW is congruent to XY, which is given. I'm going to mark that congruency, XW and XY. My next statement, given, says that XZ bisects angle WXY. Okay. Not a congruency statement, so I can't mark anything yet, but if I use that statement, XZ is bisecting angle WXY. So this angle is being bisected, which tells us what? What does it mean if the angle's being bisected? What do I know? The angle is being bisected. So what do I know is congruent? I need angles. This angle and this angle are congruent. So angle WXZ is congruent to angle YXZ. And what is my reason? Definition of angle bisector. What else do I know to be true when I look at my picture? Okay, I've got that shared side, so I know that XZ is congruent to XZ. What's the reason? Reflexive. So, now when I look, mark that reflexive piece. I have side, angle, side, side, angle, side. So I can write my proof statement. WXZ is congruent to triangle YXZ, and that is side, angle, side. So again, start out with that given information. We see us using some of those different triangle hints: reflexive property, vertical angles, midpoint, angle bisector. So different things that we've learned previously that we're going to continue to use. So 2 shortcuts we learned today: side, 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 angle, side. Okay, there are 3 other shortcuts that we will learn about in this unit.